So let's work one now where we have to find a common denominator. So this one, they are not the same. So I've got to find the number that both of these go into. And I have several factors here. I want to find the smallest number that both 5x and 15x squared will fit into. 5x is a factor of that, and 15x squared is a factor of that. So I'm going to write it like this. This is 5 and x, and this is 3 times 5 times x times x. So I've got to think about, and I know this may seem like the hard way to teach this, but it's going to make it easier when we get into something that's more difficult. So the smallest number that both 5 and 15 go into would be 15. The smallest number of x's that both x and x squared would fit into would be x squared. So then I have to think, what do I take times 5x to get 15x squared? I would have to multiply 5x times 3x. So since I multiplied the denominator by 3x, I have to multiply the numerator by 3x. So my new numerator is 21x. Here I didn't multiply this times anything to get that, so the 4 gets to stay the same. So now I have this many parts out of this, plus this many parts out of this. So since the denominator is the same, now I'm ready to add the numerator. So the answer would look like that. Since nothing factors here, I won't be able to cancel anything within the denominator, so that one stays just like it is. Let's do this one. 5 over 7 minus x plus 3 over x minus 7. If you notice, these look really familiar. They're almost the same. This one is positive 7, negative x, and this is positive x, negative 7. So I could make those the same if I took one of them and multiplied it by a negative. So if I multiplied this one times a negative, or factored a negative out of it, I would end up with negative 7 and positive x, right? Negative times x is negative x. Negative times negative is positive. So from the very beginning, when I see that they're the same except for the signs are flipped for each number, I'm going to factor out a negative. So here's the new problem I'm dealing with. 5 over negative 1 times x minus 7 plus 3 over x minus 7. So when I find my common denominator, in order for this denominator to fit my new denominator, I need a negative 1 and I need an x minus 7. So this top part is going to be the same. I'm going to go ahead and make one big denominator here because I know that I'm going to eventually put them together. But on this one, what am I missing from here that I have down here? A negative 1. So I'm going to have to take this times negative 1 to make them the same. So this becomes now minus 3. So then 5 minus 3 is 2 over negative 1 times x minus 7. And it seems weird to leave your answer like that, but you will. You don't have to multiply the negative 1 times x minus 7. You can leave it like that. As long as you put parentheses, your answer will be counted correct in Delta Math. And if you saw this on the ACT, they wouldn't multiply it out either. They would just leave it. Let's do another one like that where the numbers are the same, the signs are just different. So let's try this one. 7x plus 2 over x minus 6 plus 5 times 6 minus, or over 6 minus x. So notice these are the same, except for the signs are different. Here it's positive x, negative 6. The other one's positive 6, negative x. Let's see if we can't make those the same. I like to leave mine like this, where it's the x and then the number. So I'm going to change that one by factoring out a negative 1. So if I factor out a negative, this becomes positive 6. oops, sorry, this becomes negative 6, and this becomes positive x. So now I have a common denominator of negative 1 times x minus 6. So what did I multiply times this to get this? That would be a negative 1. And here I'm not going to multiply anything times this, so the 5 gets to stay the same. So now I'm going to write my new numerator. This would be negative 7x minus 2 plus 5. This time I have some like terms I can put together. The negative 2 and the positive 5, so my answer is going to be negative 7x positive 3 over negative 1 times x minus 6. And I don't need to worry, the top part doesn't factor, so nothing's going to reduce. So I can leave that one just as it is. All right, let's do this one. I don't remember where we're at on number. This is number 8. So this one's going to be a subtraction problem. No big deal. From the very beginning, I'm going to change it to a positive and add and make that a negative 2. Notice that these denominators don't look alike at all. There's nothing about them that makes them be common. So in order to get the common factor, I'm going to have to put both of those factors in my new denominator. So my new denominator has to have x minus 1 as a factor, and it has to have x plus 3 as a factor. So then I have to adjust my numerators. What do I take times x minus 1 to get this? The thing that's missing is the x plus 3. So the x plus 3 was missing, so I have to multiply this times 3 times x plus 3. So part of my new numerator is going to be 3 times x plus 3. What would I have to multiply times this to get this? I would need an x minus 1. So I'm going to have to take this times x minus 1. So I'm going to have negative 2 times x minus 1. So now I'm going to adjust the numerator. 3x plus 9, so I'm just distributing, minus 2x plus 2 over x minus 1 times x plus 3. And then I can put my like terms together. 3x and negative 2x is x. 9 plus 2 is 11 over x minus 1 times x plus 3.